In this video, we are going to start working on our new message activity. So what I want to do is I want to start putting together the camera preview that'll appear in the background of this activity. So yeah, let's go ahead and get started. So what we're going to do is we're going to be using an older camera API directly in our code, as opposed to sending the responsibility to take the picture off onto another app like what we did with the profile avatar image. And the reason we're doing that is I want to be able to have a camera preview inside of the application itself. Now, I did say it was an older API. In fact, it has been deprecated. We are using a deprecated API, but unfortunately, we really have no choice. The way that Android is, they deprecated this API. They created a new camera API for Lollipop, which is a lot better, honestly. But for practical reasons, you're pretty much not going to be wanting to write an application that only depends on the newer camera API for a little while to come. So yeah, we're going to be using the older one, and it works just fine for our purposes. There's a lot of quirks, and we're going to have to do some image processing on some of the images and so on and so on. It won't be all that pretty, but it'll be straightforward enough. And the concepts that we're going to be looking at also apply to the newer API as well. So I really recommend learning this API first and getting a handle on it, because not only are you going to have to be doing this for production apps anyway for a while until Lollipop overtakes KitKat, but you're also going to learn how to deal with some things that you'll also have to learn how to deal with anyway if you use the newer APIs. So yeah, the first thing I'm going to do is let's go ahead and create our layout. So I'm inside my new message activity right now. And then on the YourCreate method, I'm going to say set content view r.layout.activity new message. I'll hit Alt-Enter to import the R class, and then I'll hit Alt-Enter to create our layout resource. For our root element, I'm going to use a frame layout, and then I'll hit Enter. All right, so this is our awesome frame layout. Now, in here, all I'm going to do is I'm going to create an ID. I'm going to give the actual frame layout an ID. I'm going to say ID, and I'm going to call this activity new message frame. And the reason I'm doing this is because I'm going to actually be creating or instantiating a view in code and then dynamically adding it to the frame layout. That's because in this video, we are actually going to be writing a view. So before we go on to instantiating the view and dumping it in our new message activities frame, let's go ahead and stub that view out real fast. Just create the class so that we can reference it. So inside of my views package right here, I'm going to right click and I'm going to say new, create new Java class, and I'm going to call this camera preview. So this view is going to be responsible for showing the camera view. I'm going to delete that comment there. And what this guy's going to do is he's going to be a view, but he's going to inherit from surface view. Now, the surface view class is a class that allows you to get direct access, basically think of it as able to get direct access to pixels and have it be rendered on a separate thread. So the surface view is a very flexible sort of super low level view that allows us to render things very quickly on a separate thread and have it appear on the main UI. Now, the surface view does require that I inherit some methods. So actually, let's go ahead and do its constructor first. So I'm going to say public camera preview. Now, the camera preview class, this camera preview class is going to take in a base activity, and it's simply going to say super activity, for right now anyway. The next thing I want to do to stub this out is I want to create a public void set camera method. Now, the set camera method is going to accept a camera, and the camera that I'm going to have it accept is the one from Android.hardware. Notice the strike through. The strike through means that this API is deprecated, but unfortunately, like I said, we really don't have much of a choice with what we want to do here. So I'm going to say camera, and then I'm going to say camera.cameraInfo. Now, I'm just stubbing this out so we can invoke these methods from our new message activity. We're not going to implement them quite yet. So that's really all we need to do, at least at this point. So let's go ahead and jump into our new message activity. And for this activity, I want to go ahead and implement the bare minimum. So the new message activity, his responsibility at this point for this video is going to be to get a reference to a hardware camera and then take that reference and then pass it in to our camera preview. We're also going to allow us to switch between the different cameras on the device, typically a front-facing camera and a back-facing camera. So we'll need to keep track of which camera we are currently looking at. So yeah, let's go ahead and get started. The things that I need to do up top for right now is I am going to go ahead and create a tag preemptively. I'm going to say private static final string tag equals new message activity. This is for our logging. And then I'm going to go ahead and say private static final string. And then for this, I'm going to say state underscore camera underscore index, which is state camera. Oh, come on. Index. This is so when the device is rotated, we know what camera we're currently looking at. So, so those are going to be the constants that we need for this video. Then let's go ahead and create the fields we need for this video. So I need to do private camera. Now I'm importing Android.hardware, camera. Private camera.cameraInfo, camera info. Private int current camera index. And private camera preview, camera preview. So our camera preview is our awesome class that we just stubbed out. Our camera is a reference to the current camera we're looking at. Our camera info is more details on that. And then we have a current camera index. So now what I'm going to do, the first thing I'm going to do here in OnYura-Create is I'm going to tell this activity to never cause the screen to go blank. I'm going to say get window.add flags, and I'm going to add window manager .layout params .flag keep screen on, so our screen never goes blank. That should be pretty self-explanatory right there. Then what I'm going to do is I'm going to say if saved state does not equal null, if our bundle does not equal null, which means the activity has been destroyed and recreated for whatever purpose. Maybe the screen was rotated, or maybe the user stepped away from the application for an extended period of time, and the operating system reclaimed its memory. Then I'm going to say current camera index equals saved state get int state camera index. Then I'm going to say else current camera index equals 0. Now, I know the default value for an integer is 0, so that's really not necessarily technically required right there. I just find that to be a lot more readable when we're explicit of what its default value should be. Okay, so next up, let's go ahead and instantiate our camera preview. So I'm going to say camera preview equals new camera preview, passing in this for its constructor parameter. And then let's go ahead and add it to our frame layout. So I'm going to say frame layout equals cast to frame layout, find view by ID, r.id, frame. In this case, we're passing in activity send, oh, come on, activity send, activity new message, derp to derp, message frame. And then I'm going to say frame layout dot add view. Now this is important. I'm going to add view camera preview, but I'm going to set its index to 0. So I'm doing this overload. I'm saying camera preview comma 0. And the reason I'm doing that is because in the future we're going to have additional buttons and stuff inside of this frame layout. And I want the camera preview surface to be all the way at the back. I want it to be the for him to appear before the buttons. So we need to make sure that we set that to 0. Okay, so let's go ahead and do our on pause and on resume. Now this is going to look interesting here. I'm going to start off with on resume, because on resume is going to be pretty straightforward. On the on resume method, I'm going to say establish camera. Now that's a method I haven't created yet, but the establish camera method is simply responsible for getting a reference to the camera from the operating system. Then I'm going to do an override public void on pause, which will call through into super.onPause. And the onPause, I'm going to say if camera does not equal null, meaning we're currently we have a camera reference hooked up and we're looking at it, then I'm going to say camera preview dot set camera null null. So I'm going to clear the camera out of our camera preview. Then I'm going to say camera.release, and then I'm going to say camera equals null. So what is going on here? Oh, well, we're just saying if this activity is paused, release the camera and set the preview to blank. Why would we do that? Well, it turns out that when you get a reference to a camera on Android, that's it puts an exclusive lock on that camera. So we want to make sure that other devices, if the user decides to switch activities and switch to maybe a different application, that we don't have the camera still locked. So we make sure that when we pause the application, we release the camera. All right, now let's go ahead and let's do something simple first. I'm going to go Alt Insert Overriding Members, and I'm going to say OnSaved Instant State. Now for the OnSaved Instant State, the first thing I'm going to do is call through the super. Then I'm going to say state.putInt, and I'm going to say state underscore camera index, current camera index. So I'm saving out the current camera index into the bundle, so if the user rotates the device or comes back, we know what camera we're looking at. All right, now for the more interesting method here. So I'm going to do private void establish camera. And remember, the establish camera method is invoked on resume. It's also going to be invoked when the user presses the button that we don't have yet, to switch the camera to the front-facing camera. Now, establish camera is first going to say if camera does not equal null, then camera preview dot set camera null null, camera dot release, and camera equals null. So, or equals null. So what that's doing is that's saying if we're reestablishing the camera or establishing a new camera index, go ahead and release the old camera we had a reference to. Then I'm going to say try camera equals camera dot open current camera index. So camera.open is a method that will establish a exclusive lock on the camera resource and return it back to us. But it can throw an exception. So I'm going to say catch exception E. And for this, I'm going to say log.e. So this is why I wanted that tag up there at the top. Could not open camera plus current camera index, comma E. So we'll get a nice message in our log of why that failed. Then I'm going to say toast.makeToast this error establishing camera toast length long dot show, and then I'll say return. So we log to developers that something happened, something bad happened, we couldn't establish the camera. Then we show the user a generic error message, and then we just exit the method, which will keep everything blank. All right, so now what I want to do is I want to get camera info. So I'm going to say camera info equals new camera.camera info. And then I'm going to say camera dot get camera info, passing in the camera ID, which is the current camera index, followed by camera info. So this method will populate the camera info structure with additional data about the camera that we just established. And then I'm going to say if camera info dot facing equals camera dot camera info dot camera facing back, then I'm going to say toast make toast this using back camera toast dot length short show, otherwise toast make toast this using front camera toast short dot show. And that's it. So again, this new message activity class is mostly responsible for establishing the camera, releasing it when it needs to be, and then telling the camera preview to start using that as a preview. But if we went ahead and we looked at, if we ran this application right now, nothing would be visible. Yeah, we would still be getting a reference to a camera, but nothing would yet be visible because we haven't implemented our camera preview. So let's go ahead and do that. I'm going to jump into the camera preview class, and we're just going to go from top to bottom, I guess. The first thing we're going to do is we're going to declare our fields. So I'm going to create a private final surface holder, which the surface holder is responsible, if you look at it, it's responsible for things like, well, basically changing the surface. It's responsible for drawing pixels to the surface. It's responsible for handling callbacks. It's responsible for that sort of thing. So you can think of the surface view as more or less a view on our view hierarchy, but it's just a wrapper for a surface holder. Next up, I'm going to say private camera. We need a reference to our camera. And a private camera info. We need a reference to that too. And then a private boolean is surface created. So the surface might not necessarily be created yet, and that will change the behavior of some of our code. So we're going to keep track of whether or not the surface is created with this boolean. For our constructor, we're simply going to go is surface created as false, initialize that to its default value, and we're going to say surface holder equals get holder, and then I'm going to say surface holder dot set or add a callback this. So what's going on here is we're getting our surface holder, but then we're adding a callback of this object, and that will have it so that the surface holder will inform us when it's been created, which is very important. You'll see that in a second here. I'll go ahead and put my keyboard cursor on those squiggles, and I'll hit Alt-Enter, and then I'll select Make Camera Preview Implement, hit Enter, and then hit Enter. And you'll see that the surface holder callback interface requires these three methods: surface created, surface changed, and surface destroyed. We'll be handling these in a second here. The most important method I would say in this class is going to be the set camera. So what we're going to do is I'm going to say if camera does not equal null, which means if, or whoops, I'm missing an equals there. That means if the camera is not null, so if we're resetting the camera to a new camera, then I'm going to say try. Well, I guess I could say if camera is not null, if camera equals this dot camera, return, just in case they're saying they're setting the camera to the same thing. That's just a sort of sanity check right now. Otherwise, try camera dot stop preview catch exception ignored. Or I guess I can go ahead and log it. Sure, why not? Let's go ahead and add a tag up here. Private static final string tag equals camera preview. And then down here, inside of our exception, change that from ignored to E. And then say log.e could not stop camera preview E. And then we won't return. We'll just let execution happen. Of course, tag is the first parameter there. So this will stop the current camera preview, which is what we want to do. We want to make sure, because you can't have a camera preview going more than once, you want to make sure that you stop it, otherwise it'll continue trying to render to the surface and bad things will happen. Next up, let's go ahead and say this.camera equals camera, and this.camera info equals camera info. Make sure to place your this dot right there, otherwise your code's going to be not going to work, because you're going to be redundantly assigning something to itself. Then I'm going to say, if not, is surface created, return. So if the surface hasn't yet been created, early exit out of the method because we have nothing else to do. We do not want to start a camera preview on a surface that hasn't yet been created. Then I'm going to say, try camera.setPreviewDisplay surface holder. Or, sorry. Nope, that's right. I'm stupid. Then I'm going to say, configure camera. And then I'm going to say camera.startPreview. Then I'm going to put a catch here. I'm going to say catch exception E, log E, tag, could not start camera preview, passing in E. All right. So what I'm going to do here is, ooh, I just noticed a bug. Thank you for that, IntelliJ. I just noticed a massive bug. I hope you guys noticed the same bug here. Why is it, just a really quick exercise for everyone, why do you think that background there is highlighted? So I put my keyboard mouse cursor on it. You can see method invocation may produce a null pointer exception. Now that's kind of odd for IntelliJ to say that, right? Because basically anything could produce a null reference exception. So why would it choose now to make that really, really obnoxious thing right there? Well, it's actually doing some hardcore analysis against my code, and it's determined that a null value of camera is an acceptable value for this method. Now, why would it do that? Because up here I check to see if camera is not null, but I'm accessing it inside or somewhere where I'm not checking to see if it's not null. So IntelliJ sees you're checking to see if camera does not equal null, then you're using it. Well, that doesn't make any sense, because by you checking for it not to be null, that implies that it could be null. And if it could be null, then you're just ruined everything. Now, the problem is, the whole problem of why this is happening is because this if camera does not equal null should be if this dot camera does not equal null. And this dot camera, or whoops, camera equals this dot camera, and this dot camera dot stop preview. So now that's because I was wanting to access my old camera, not the one that was passed in as a parameter, but they're the same name. And because Java discourages field prefixes, which I think is not a good thing, you have to prefix it with this dot. See, this is why I really like field prefixes. Just because of that, I almost introduced a potentially terrible, difficult to debug bug into the code because we're not using field prefixes. So if that's not an argument for field prefixes, I don't know what is. Actually, you know what? We probably should remove this if camera equals this dot camera check here. There's a potential for the camera not to be reset when the activity gets resumed. So I'm just going to nuke these lines right here, and then we will move on. Anyway, all right, so let's go ahead and just work down here. Let's do our surface created. Now our surface created, pretty straightforward. I'm going to say is surface created equals true, but then I'm going to do something else. I'm going to say if camera does not equal null, then set camera info. So basically, what would happen? How would this happen? Well, this would happen if the user set the camera to something, if the programmer set the camera to something before the surface was created. In that case, remember this code up here? All it does is sets camera to camera and camera info to camera, but then if the surface isn't created, it returns. So if the surface then gets created at some later point, we want to go ahead and say if the camera does not equal null, meaning the camera, someone tried to set the camera, but they didn't set it for reals because the surface wasn't created, then reset the camera now that the surface has been created. All right, on our surface changed, I don't care about that. That's not a big deal. On our surface destroyed, however, I'm going to say if camera is null or surface holder.getSurface is null, then return. We don't have anything left to do. Otherwise, I'm going to say camera.stopPreview. And then catch exception E log.e tag can't stop preview E. Alrighty. So the next thing I want to do is I want to change the behavior of how this view is measured. So I'm going to go ahead and say override method, and then I'm going to say on measure. And so we're going to override the on measure method. I'm going to go ahead and for this, I want to basically receive or resolve the size in a particular way. So I'm going to say, I'm going to change this to on measure width height. I'm going to say width equals resolve size, get suggested minimum width, and height equals resolve size, get suggested minimum height, and then I'm going to say set measured dimensions to width and height. So that'll fix some stretching issues with our camera preview. Now the last thing I need to do is write the configure camera method. So there's actually going to be two methods we need to write, and it's going to be an interesting thing about this API. I'm going to say private void configure camera. And for configure camera, the first thing I'm going to do is extract the camera parameters. So I'm going to say camera.parameters equals camera.getParameters. So I'm extracting the parameters object from the camera, and then I'm going to manipulate them. So what I'm going to do here is I'm going to say camera.size target preview size equals get closest size, which is a method we haven't written yet, get width, get height, parameters, get supported preview size. Where are you? Get supported preview sizes. And then I'm going to say parameters dot set preview size, or set preview size, not format, to target preview size dot width and target preview size dot height. Then I'm going to do the same thing, but for the actual size of the, so I'm going to say target image size, which is the target size I'm going to be using for the actual image that's taken. I'm going to say get closest size. And for this, I'm going to pass in 1024.1280. And then parameters get supported picture sizes. So, and then I'm going to do parameters dot set picture size, target image size dot width, target image size dot height. And then finally, I'm going to say camera dot set display orientation to 90 degrees because we're assuming portrait here. And then I'm going to say camera.setParameters. So what this method's doing is it's setting up the dimensions of both the preview of the camera as well as the image that'll be taken. And we're going to be using those two different values here. And, there you go. And the first one is the preview. And what we want to do is I want to write a method here called getClosestSized, which will receive a list of supported sizes and then a list of my desired size, and then it'll return the closest size to that. So what I'm doing here is, like, for example, the every camera will have a list of supported resolutions, essentially, and I want to make sure that the resolution I'm using is the closest to the actual size of this control on the screen as possible. So that's what I'm doing there with the getClosestSize. I do want to see what's wrong with this. Target image size width, target image size height. Oh, it's set picture size is what I want, not set picture format. All right, so let's go ahead and implement our getClosestSize here. It's just going to be a couple loops. It's pretty straightforward. Private camera.size, and we're going to say getClosestSize, and we're going to fix that spelling right there. And getClosestSize is going to receive an int width, which is the target width, the target height, and then a list of camera size supported sizes. I'll import list. Now I'm going to say final double aspect tolerance of 0.1. So what I'm doing here is I'm creating a private constant field, or a private constant local variable, that's going to determine how close to a target size that we're allowing ourselves to get in relation to aspect ratio. So then I'm going to say double target aspect, or target ratio, equals cast to double height divided by width. So that's the target ratio that we want. And then I'm going to say camera.size, target size equals null, double mindiff equals double dot max value. I don't like that name. Minimum difference. And so what's going on here is our target size is what ultimately our chosen size is going to be set to. Our minimum difference is we're going to keep track of how close to the aspect ratio that we got, or how close to the height that we got during this for loop. So I'm going to say for camera.size in supported size. I'm going to say double ratio equals double size.width divided by size.height. And I'm going to say if math.abs ratio minus target ratio is greater than our tolerance, then simply continue on the loop. So if the ratio of the current supported size that we're looking at differs from our target ratio by more than our aspect tolerance, which right now is 0.1, then just continue and don't consider this. Otherwise, consider this. And I'm going to say if math.abs size.height minus height is smaller than min.diff, then I say target size equals size, and min.diff equals math.abs size height minus height. We could go ahead and alias this out into a local field or a local variable so we don't have to do it twice. So I'm going to right-click this, select refactor, and then on the menu that popped up above where you guys can't see it, I'm going to select extract variable, and I'm going to say replace two occurrences, and I'll call this height difference, and we'll go from there. All right. So now, what if no supported sizes were within our aspect tolerance? Well, then I'm going to do the loop again, but I'm going to consider every aspect ratio as appropriate. So I'm going to say if target size is null, then I'm going to set up my min difference back again to double.max value. And then I'm going to say for camera.size in supported sizes. Then I'm basically going to do the same thing here. I'm going to say int height difference equals math.abs size height minus height. I'm going to say if height difference is smaller than the minimum difference, then I'm going to say target size equals size, and then minimum difference equals height difference. Then all the way at the end, I'm going to simply return target size. So if you want to pause the video on that, a very obnoxious method to write, but whatever. Anyway, this almost completes what we have to do. The last thing we have to do is we have to add in a permission to allow ourselves to access the camera. So I'm going to do that. I'm going to scroll all the way up here to my Android manifest. I'm going to scroll up here where I have my uses permission. And I'm going to say uses permission camera. And that'll allow us to access that API. All right. So now I'm going to go ahead and go on new message activity. I'm going to right click. And before I do that, actually, I will do one thing. I'm going to go ahead and I'm going to find my emulator or my virtual machine where he ever ran off to. It's right here. And I'm going to enable my my camera emulation. So my camera emulation right now is on because I was testing things earlier. But when you start this, you will probably have this set to off. So go ahead and hit this ridiculously difficult to see toggle button. And then from your front camera or your back camera, select either the dummy webcam or a physical webcam you have plugged in. And this is what the dummy webcam looks like. It looks like just the Genymotion thing running around. So I'll select none on the preview. And then I'll go ahead and exit out of that. Now that I have my webcam emulation turned on, I'm going to right-click my new message activity, select run, and wait a little bit. What we should see is error establishing camera. So let's go ahead and take a look at our logcat and see what happened there. Could not open camera 0. Failed to connect to camera service. I'm seeing stuff like this. I typically, the first step, I don't know if this is going to fix the issue or not, but typically my first step is to restart my my virtual device. The camera, unfortunately, with this guy is with Genymotion in general is I found it to be fairly finicky. I found it to be one of the lesser reliable features of this particular device. So let's go ahead and restart it. And it's restarted. Let me go ahead and enable my camera, my webcam, or my camera preview here, using the dummy webcam. And then I'm going to go ahead and hit run again. And I'm running the new message activity directly, just like how I did before, so we can get quick testing here. And we still see an error establishing the camera, so that's interesting here. Let's see. You know what it is? You know what it turned out to be? My Android manifest. I am, for some reason, I guess the autocomplete decided to start yelling at me for whatever reason, and wrote out our Android.permission in caps when it shouldn't have been. So let's go ahead and fix that. I'm going to change that to, see, it's doing it again. I think actually it's a bug in IntelliJ, because if I do this, notice how it's in lowercase right here, but when I hit enter, it's in uppercase. So I think that's a bug with IntelliJ itself. So I'm going to go ahead and manually change the casing on that. There's also another problem where I never actually set the camera on my camera preview to the camera that I established. So go ahead and jump back into your new message activity, find your established camera method, and simply say camera preview dot set camera, passing in my camera and my camera info. So now that I've done that, I'm going to go ahead and hit play, and we should be good to go. As you can see, we now have our back camera. So yeah, I think that's all I wanted to do in this video. In the next video, we'll go ahead and start putting together the rest of the UI and the image processing that we're going to have to do with our new message activity. So we'll see you guys in the next video.